what I want to do, so the one thing when I talk about matched pairs, your ends have to equal. Okay? So this is kind of a silly example, but I'm going to tell you anyway. Going back to the following meter stick, I measure the right hand, or the left hand in this case, but the person has no right hand. What do I do? What do I do with that data? I've got the left hand. What do I do with the data?
Roll it out.
Roll it out. Okay? If you don't have a pair, you don't have a pair. You have to have, your ends have to be equal. You gotta have an actual matched pair. Okay? So that can be a tricky thing. You know, one of my favorite test questions is I say, hey, is there a difference between these two tests? And a lot of times I use real data. And the person showed up for test number 1 and they didn't show up for test number 2. And then you have to remember, oh, I gotta throw out that data because I don't have a pair. Okay? It's a mean thing. Now, one of the things that I will have to say, so in dependent samples, your ends have to match. In independent, they don't. Okay? But in a dependent, they've got to match. Okay? So I'll make that really clear today so that you'll forget about it when I put it on the test. Okay? So don't forget. Okay. So let's open up one of the worksheets here. I've got here, go to your assignments, go to your in-class worksheets, worksheet 11.1 and 2. Okay. All right. So, I actually want to go to 11.1 here. Now, one of the things that I just want to emphasize, I emphasize that we're measuring the differences here. Okay, so this is our example. The following meter stick, I'm assuming these are in seconds. Okay? Now, let's find the differences. Because remember, I'm more concerned about the differences than I am about the underlying populations. Now, when I do this, it doesn't really matter if I do x minus y or I do y minus x, as long as I'm consistent. Okay? So, I'm going to copy that formula down, and let's talk about the mean difference. Okay? I'm going to do the average of all of these. So we can see that the mean difference is a negative number here, negative 0.01. So let's think about this for a minute. If this is my dominant hand versus my non-dominant hand, I think give you guys a lot of directions here. But do you think that your dominant hand would be faster or slower than your non-dominant hand?
Faster.
So if I'm taking your dominant hand, the faster, minus the slower, would you expect that number to be negative? Yes, you would. Okay? Okay, so let's start going through our steps here. Okay, so that's the one thing with the matched pairs that I'm going to just point out there. We're looking at the differences. Okay, so the first question is, this is on the test next week, and I don't warn you that it's in this section, is this quantitative, categorical, or regression? Quantitative. Okay, a lot of numbers there, right? And we're subtracting them. Okay, now remember, earlier this week we had a lot of numbers and it was categorical. Okay, so you gotta make sure. Okay, so step number 2 is okay? Now, in this case, I'm going to give this one to you because I don't think this one's going to be really super clear. Okay, now remember, we're concentrating on the differences. Okay? So, in this case, when we're doing a matched pair thing, the null hypothesis is going to be that your difference is 0. is no difference between your left hand and your right hand. We always assume there's no difference. Oh, you're playing Taylor today? Okay. All right. Now, in the book, I think it's easier to write as d equals 0. Your difference is 0. In the book, they put mu sub d equals 0. Okay? Same thing. Okay? So, when you're on your computer, that's a whole lot easier to write for this. So that I'm totally fine with that. Okay? Now, as we're thinking about this, let's think about your alternative hypothesis. Okay? Your alternative hypothesis, what should it be?
Does not.
Okay, so I heard a less than 0 and I heard a not equal to 0. Okay? So, as we think about this, now that I didn't give you guys there's not a lot to read through here. As you think about this, wouldn't you expect your dominant hand to be faster than your non-dominant hand? Okay, so in this case, I would say difference is, in this case, less than 0. However, what if, instead of saying x minus y, I did y minus x? What would your alternative be in that case?
Greater than.
It would then be, in that case, d is greater than 0. Okay, so it depends on how you define this. So in my case, I did x minus y. But if I did y minus x, you would expect your difference to be greater. You would expect the slower hand to be greater than your faster hand. Okay? So this kind of depends on how you define it. Okay? In our case, we said the faster hand minus the slower hand, we're going to say the difference is less than 0. If we don't know, we would simply do a two-sided test. Okay? The safest thing to do is a two-sided test. You don't know. Okay? In our case, I think the case can be pretty strongly made. Yeah, you think your right hand's really fast with the right. So we're going to go d is less than 0 in this case. Does that make sense? Okay. Next, go ahead.
So if something like this came up on a test and we didn't really know, we did it two-sided, would we miss like the whole question?
You wouldn't miss the whole question, you would just probably get your p-value wrong. So, okay? All right, so next question is, what kind of a statistic should this be? That's a statistic, right? Would you like to give you a multiple choice here? It's going to be a z, a t, pi squared, or, I don't know what, I'll just call that out. So based on what you know, what do you think the answer should be?
C.
T. Why do you say T? Because why? We don't know the population standard deviation. Does anyone out here know how quickly you can catch a meter stick off the top of your head? Okay? Yeah, we don't know. Okay? So this is definitely going to be a T distribution. Okay? Which means it's time for the equation of the day. Okay? So it's definitely a T. So we're saying D is less than 0. So this is going to be a T statistic two-sample dependent. Or you could also refer to that as matched pairs. Now, I just want to mention this, I should have mentioned this a little bit sooner. The most difficult test for people to choose is it a paired sample or is it an independent sample? That's going to be the most difficult for you to choose. Okay? This is the easiest one to mix up. In our case, it's dependent sample is matched pairs. T, this is the equation I'm going to give you, is d bar over s sub d over the square root of n. Now, in your book, they give you, or in your thing here, they give you a slightly different thing. They say minus mu sub d. Why do you think I didn't put that in the formula?
0.
Because it's 0 because of what? your null hypothesis, okay? That's always going to be 0 under the null hypothesis, okay? So just make sure you remember that. Okay, so in this case, so I've got my e bar. In this case, t equals my e bar, which is negative 0.01317 divided by, what do you think S sub d stands for? Standard deviation of differences. Okay? So once again, I'm concentrating on differences. Must be the EV of all of this stuff. Okay? So my standard deviation is 0.016421. Divide that by the square root of. Okay? So in this case, I've got differences, and I'm going to divide that by the square root, and divide that by standard deviation divided by the square root of 12 in this case. I'm going to divide those two numbers by that. Gives me negative 2.77. Okay? So what's going on? On the picture, right? What's the mean? 0. I am negative 2.77 sort of standard deviations away, right? Is this a one or two-tailed test? One-tailed test. So how do I find my p-value with the chart? Okay? So I'm going to go over to here, go to my t-chart. How many degrees of freedom do I have?
11.
11 degrees of freedom. And by the way, this tells me the area to the right. What do I want? Area to the left. Okay? One-tailed test, right? By the way, these are all positive numbers. I've got a negative number. What does that mean? Pretend it's negative because it's symmetric. It doesn't matter. Okay? So here I am on 11 degrees of freedom. I'm looking for 2.77 along this line here. 2.77. So I'm in between these two numbers here, right? So I'm in between those two numbers, which means I'm in between those two numbers. So my p-value is in between 0.005 and 0.01. Okay? Now, how would I do that with the computer? Equals this, you got this, okay, which one? The first one. First one's going to be a left-tailed test, right? We're going to put in this, and degrees of freedom is 11. Do I want the cumulative? True, yes I do. Okay, so the true p-value is 0.009, which is very close to this end. Really not that far apart. Okay? Alright, so now what do I do? Reject or do not reject? What?
Compare with 0.05.
Yeah, so compare with alpha. What's my alpha?
0.05.
Didn't tell you, so we use 0.05. So I reject, which means there is a significant difference, and there is evidence that dominant hand is faster. Okay? All right, now, of course, we can also do a confidence interval, right? Let me give you the formula for the confidence interval. So the interval for your confidence, the formula for your confidence interval is z bar plus or minus t sub alpha over 2 times s sub b over that. Okay, very similar. This is your margin of error. Now, the one thing that I want to point out here, we did a one-tailed test right here. Okay, what's your confidence interval? Confidence intervals are always two-tailed, right? Okay. If, in this case, if my alpha is 0.05, if I want to do a 95% confidence interval, how much area is in each tail? 0.025 and 0.025. Now, if I do this, which I'm more than welcome to do, remember, these are two different pictures going on. So these could disagree, because I'm doing two different things. Okay? So let's do this. We're going to do a confidence interval, but these could disagree. Let's see if they do disagree. Okay, so my confidence interval. In order to do my confidence interval, I'm going to find a theta of alpha 2. I got my lower, got my upper. How do I find my t sub alpha over 2? 0.025, 11 degrees of freedom. That gives me 2.201. Okay? So 2.201. This is going to equal your d bar minus t sub alpha times s over the square root of n is 12. So I'm going to take that, I'm going to copy it. I'm going to change that to a plus. Now my question to you all, okay, these are measuring slightly different things. Does this, try to put it this way, does that agree with that conclusion there? Or does it disagree? It's negative on both sides.
That means it doesn't include 0, that means you would.
So it doesn't include 0, so that means
You would not reject, right? You would, oh yeah, you would reject.
you would reject. You would reject it all. So, does this tell me that there's a significant difference, that the dominant hand is faster? Yes. In this case, both of them are negative. D bar is the mean of all your differences. Okay? So these do agree. Okay? That's a great test question, huh?